Lesson 20. We skipped lesson 19. We'll catch it tomorrow. Lesson 19 is one of those that we really don't even need to cover. It's got problems like solve x minus 2 equals 8. I mean, it's solving one step in equations that involve addition and subtraction. Very, very, very reviewish, right? Yeah, you do it a lot. So anyway, we're not going to have homework on that lesson, so that's a good Wednesday lesson for us. And we'll cover that briefly after the quiz, just kind of run through the examples to make sure that everybody has it. All right, so today is not much more difficult than that. We're learning to graph on the coordinate plane. You've done this before, so we're going to kind of run through the stuff at the beginning that's really, really simple, and you know how to do it already. And then we're going to get to a couple of new concepts, not difficult concepts, but new, that you need to kind of have, we'll spend a little bit more time on. So first of all, what is the coordinate plane? Right. Yes?
It's like, it's quadrants.
4 quadrants. Yeah.
Yeah, and then it has a y-axis and an x-axis.
Yes, x-axis is horizontal and the y-axis is vertical. So, you know, here's the description. I like this textbook definition of it. The coordinate plane is made up of 2 perpendicular number lines. You got one vertical number line and one horizontal number line, right? That's pretty easy to do. And together they form the coordinate plane. The horizontal line is called the x-axis. You don't need to write this down. You really don't. The vertical line is called the y-axis, and it divides the plane into 4 quadrants, right? So that's just about everything that Elijah just said we just talked about, right? That's what the coordinate plane is. Another name for the coordinate plane is the Cartesian plane. Have you ever heard of that?
No.
It's called the Cartesian
You guys know that.
plane.
That's how you spell it?
You know, just a little bit of
That's an E after the T, right?
Cartesian, yes. It's named after the person, I'm guessing, that had something to do with it, and his name was René Descartes. Okay. René Descartes. He was a French mathematician, and so this Cartesian plane, maybe it kind of it goes back to him in some ways. Maybe he kind of formulated it and did something to it. And then mathematicians are notorious for naming things after themselves, or we name the thing after them post-mortem, right? So the number line divides the plane into 4 quadrants. And let's see what else we have here. The intersection of the x and y axis is called the origin, right? That's the point right in the center. That's where the 2 number lines intersect. The coordinates are indeed 0, 0 of that deal. So, all right, so here's a picture of what we just described in words. And this is important. I want you guys to understand that everything here is important. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. What do you notice about the way those are named? It's counterclockwise. Okay, I want y'all to listen very carefully. Everything in geometry, everything in trigonometry is counterclockwise. If you're rotating something, it's counterclockwise. It's going to bite you. I'm telling you now, it always goes with the quadrants and the way they're numbered. Angles in the coordinate plane go in that direction. Okay, vectors in the coordinate plane, degrees, measurements go in that direction. Okay. So trigonometry, it's got some important concepts too. So being familiar with those 4 quadrants and knowing where they are is extremely, extremely important beyond the little confines of our nice, easy peasy Algebra 1 class. Okay? There's a lot of tie-ins to this later on. All right? Now, the coordinate plane, each point on the coordinate plane is identified by an ordered pair or 2 numbers in parentheses separated by a comma. Ordered pair is written as follows, x, y, and the ordered pair that represents the origin is 0, 0. We already know all of that stuff, right? How can you keep that together in your head there? The ordered pair.
Oh, alphabetical?
Do what? How can you keep this X, Y? It's what?
It's alphabetical.
Alphabetical, exactly right. X comes before Y. And in the ordered pair, and the reason it's called an ordered pair is because it's always given in a specific order. X always comes before Y. That makes it an ordered pair. Not everything in mathematics is like that, right? A set of numbers doesn't have to be ordered in any certain way. A set of collection of objects doesn't have to be ordered. But ordered pairs are. Ordered triples if we're graphing in a three-dimensional space. X, Y, Z plane. Okay? It's ordered. The order of the things is important. Okay? The ordered pair that represents the origin is 0, 0. So we can make a little bit more. We can go a little bit farther and talk about the first coordinate is the X coordinate. The second coordinate is the Y coordinate. The X coordinate tells us whether we're going left or right of the origin, right? Y'all don't tune out on me. We're getting to some new stuff. I'm just trying to get through this as quickly as we can. The Y coordinate tells us how far above or below the horizontal axis we're going to go, up or down from the origin, right? So we can look at kind of a combination of things that we can do here to find a point. Always start at the origin and use the sign, the coordinate, to determine the location of the point. Left or right, up or down from the origin, depending on the coordinates of the point. Now, what is this telling us? What information is this giving us here?
That
In the first quadrant, the X and the Y
Are positive.
are positive. In the second quadrant, what does it tell us? X is negative and Y is positive. In the third quadrant, they're both negative. In the fourth quadrant.
X is positive, Y is negative.
So when you get to trigonometry, when you get to trigonometry, this may even have some relevance when you get to the geometry trig that you cover in geometry. These signs are extremely significant. It seems trivial at this point, but they become extremely significant when you start looking at trig function values, unit circle, all those things. It becomes really important. Okay, so I know this seems trivial, but it's important for you to have in your memory bank. All right, now let's put this into practice. Graph the ordered pair 4, 2. What is the X coordinate of this point? And the Y coordinate is 2. So what are we going to do?
Over 4 and up 2.
Over isn't descriptive.
To the right.
To the right 4 and up 2. So if we go to the right 4 and up 2, that's going to land us somewhere right in this vicinity. Yes?
Yeah.
Yeah?
Right there.
Okay. X is 4, Y is 2. So that's that point right there, 4, 2. You can tell it's in the first quadrant because X and Y are both positive, right? Okay. What about this point? Negative 3, 0.
Left 3 and then stay there.
Why do we stay there?
Because it's 0.
0. Now, there's an important thing here that we're going to, that's it right there, negative 3, 0. It's on the y-axis. Is that what you said?
I said that. but
It's on the x-axis. You said y. You meant to say x-axis, right? What's the coordinates of this point right here?
6, 0.
6, 0, right?
Mm-hmm.
What's the coordinates of this point?
Negative 6.
Negative 6, 0. What do all of these points have in common?
They're 0.
They have a 0 as their y coordinate. So couldn't we make a general statement about the x-axis?
Yeah.
It's always, wait.
On the x-axis, y is always equal to 0. That's an important fact. Very important fact. On the x-axis, y is equal to 0. On the y-axis,
X is equal to 0.
x is equal to 0. So those just some observations about this thing are going to help us kind of get some concepts a little bit later. All right, now here's a new concept. What's in this box here is important.
So right
Okay? Yeah, write that down. Okay? When there's a relationship between two variable quantities, one variable is the independent variable and the other is the dependent variable. Learning to recognize which is which in a word problem scenario is important. Because when we start translating word problem relationships into equation relationships and then maybe want to graph it, it's important to know which is which.
You have to do
Okay.
that in science.
You do have to do this in science, yes. The independent variable and the dependent variable. The variable whose value can be chosen. Okay? We have some flexibility. We have some control over the independent variable.
Time.
Okay? Time,
Like if you're like recording something.
Yeah. time is independent.
Sometimes, depending on
Yeah, depending on
Depending
the
on if
situation.
you're like,
if
I know what I'm thinking, but
yeah, how do you say this? Like if the time is set and it's how long it takes in that time frame.
yeah,
Then
But if
it's
you're
not time.
recording, like if it's gonna be a different time for different
like if you're trying to.
So
make-
if you have a reaction that's taking place and you want to measure the length of the reaction, then it reverses, right? Because time depends on the reaction in that case. Right? If we're waiting for something to happen, a specific thing to happen,
You don't know how
then
long.
time becomes dependent on how long it takes it to happen, right? So,
that's what we're trying to
Chickens
say.
and
They're not
hats.
really-
yes.
Time
Yeah,
is-
so time isn't always the independent variable, but generally speaking, time is independent or can be independent. We'll look at some scenarios in a moment that will give us, we'll have to choose. Another name for the independent variable, this is a little early and we'll get to it later, it's the domain variable. Y'all remember the word domain from last year at all? This may be a completely new concept in Algebra 1. The domain, and then the dependent variable is called the range variable. Okay, the range, the domain and range of a relationship. The domain is the independent variable and the range is the dependent variable. Okay?
Okay.
We're getting those words a little bit ahead of time. We'll revisit those a little bit later. Okay? Now, let's have a look at this scenario. There's two variables here. Identify the independent variable and the dependent variable. All right, so in this scenario, the variables, the quantities, are the number of traffic violations and the cost of your insurance. That's the two variables. Which one of those is independent and which one is dependent? Elijah?
The traffic violation is independent and the cost of auto insurance is dependent.
Explain why.
Because judging by like if you have a bunch of traffic violations, the more traffic violations you have, the more your auto insurance is going to be.
Right, so you don't really have control over it. Once you have a traffic violation,
Your auto insurance.
your auto insurance is going to go up. Which piece can you control and have some type of input in? Right. The traffic violations, the independent variable, that's something that you can kind of control. But once you have that traffic violation, the cost of your insurance is no longer under your control. It's dependent on the other thing, right? Okay, so independent is the input variable. You put a couple of traffic violations in the mix on your auto insurance, and it's going to just jump sky high quickly. Okay, that's true no matter what your age is, but especially true if you're a teenager, and especially true if you're a teenage boy. Just got a lot higher insurance rates. All right, what about this one? Your electric bill total and the kilowatts of electricity used. Aspen, what do you think?
Kilowatts of electricity used is independent
Why is that independent?
because you control how much electricity.
How do you control that? Come on now.
Turn on and off the
Don't tell me you teenagers know how to turn the lights on and off when you leave a room and come into a room. I don't believe it. I've never seen that in practice. What does that actually look like?
Like when we're leaving houses, they cut off the lights.
Yeah.
Yeah, I mean, we can control that. Did you ever wonder why they call it cutting off the light?
Can you cut off the electricity?
But it's electricity coming to the.
What's that, Elijah?
Like, can you cut off the money you have to
Cut
pay?
it off? Think about where that might have come from.
Oh, cutting the wire?
Taking a little pair of scissors and cutting off the wick to a...
Oh, fancy. That makes sense.
Yeah.
I tried to get
Maybe.
scissors to cut it.
Yeah.
I was
So,
thinking about candles.
the bill total is dependent on
Your amount
how
of
much you use, right? So, I mean, these are some pretty clear scenarios, but I want you to start thinking about the variable that we can control and the variable we can't control. We can control one directly. Once you control that one, the other one is affected. You can't undo it, right? If you use the electricity, you're going to pay for it. So we can choose to use or not use it. And then we go. So input, output, domain, range. Okay? Now, if we have a relationship for x and y, a solution to an equation, this new concept here, very important one, by the way. This first statement, don't write it down yet. A solution to an equation with two variables is an ordered pair that makes the equation true. Okay, so if we have two variables, we've got ordered pairs that make it true. Now, let's look at an equation that just has one variable. X plus 3 equals 7. Right? One variable. What's the solution?
4.
One solution, right? One number is the solution. Is there any other solution to this equation?
No.
It's a unique one solution because I have one variable. Now, as soon as I change that to something like this, x plus y equals 7, then I have really, really changed the game, haven't I? What's the solution to x plus y equals 7, Jack? 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 Yeah, you do. You're adding two things to get 7. Give me two things that add to be 7. X is 5, y is 2. Right? X is 3, y is 4.
7 and 0.
X is 7, y is 0. And then you could reverse all of those, right?
Yes.
6 and 1, 1 and 6. 8 and negative 1, 10 and negative 3.
Whoa.
Right? Okay. Positive 1/5
Oh no.
Oh no, fraction.
and 6 and 4/5. All right, so
I don't like this.
yeah. So when you get into that, you can see that we've created a scenario here that has an infinite number of ordered pair solutions. That's a drastic change that we made just by adding what? Another variable, right? We add a variable and we change the game infinitely. We create an infinite number of solutions. We move from one solution to an infinite number of solutions. That's a big deal, right? So there are an infinite solutions to the equation. For example, y equals 4x plus 2. Solutions can be found by substituting values for the independent variable, which they have defined to be x. So if we're comparing y and x, y is the dependent variable and x is independent. X is the domain variable and y is the range variable, the dependent one. Okay? Domain and range. D comes before R, X comes before Y. Okay? Independent and dependent. So we can make substitutions into that for X. Just pick a number for X. 2. If you put 2 in for X, what do you get for Y? No, right here.
Oh. 10.
10, right? So 210 is a solution. 210 to Yuma. It's a movie. I don't know. Never saw it. If you put 0 in for X, you get what?
0 for y. Wait, no, 2.
2 for Y, right? So we're generating ordered pair solutions just by picking values for X and solving for Y. Now you could just as arbitrarily have said Y is going to be independent and we'll plug values in for Y and solve for X, right? And you can still do that. In math, we just like to kind of keep things structured and let's say, okay, X is going to be our input variable. We're going to treat that as the independent variable and Y as the dependent variable when we're in an arbitrary situation like this. We don't really know what X and Y stands for. Right? Okay. So, complete the table. For Y equals 4x plus 2, and by completing this table, what are we finding? We're finding solutions, right? We're finding ordered pairs, X values and Y values that make the equation true, right? So if we plug negative 2 in for X, what do we get for Y?
Negative 6.
4 times negative 2 plus 2 is negative 6. If we plug 0 in for x, we get 4 times 0 plus 2, which is 2. If we plug 2 in for x, we get 4 times 2 plus 2, which is 10. If we plug 3/4 in for x, we get 4 times 3/4 plus 2, which is 5. Yes. 4's cancel, and we're left with 3 plus 2, right? Now, what do I have here? Ordered pairs, right? Ordered pairs. So we could do what with those ordered pairs? Graph those things, right? -2, -6, somewhere down there. That's down there in quadrant 3, right about there. 0, 2.
Y-axis.
It's on the y-axis because x is 0. 2, 10. Somewhere way up here, right? What have I created there? A line. Right. So this is a linear relationship, right? Now, what's the significance of that line as it relates to this equation?
They're all solutions to it.
All what? They're
Solutions.
all the points on that line are solutions to that equation. That's exactly right. Every point on there, a line is a collection of points that make a linear equation true. That's all it is. All right. Now we know this is y equals mx plus b, and you guys can recall a lot about that. We're going to learn more and more about that as the year goes on. But that's it. So a line is a collection of points that makes a linear equation true. The solutions to a linear equation will form a line. That's why it's called a linear equation, and that's why the graph of the linear equation is a line. So linear equations have that characteristic. Okay? So, dependent variable, independent variable, domain, range. Okay? Looks like a lot of words, makes you think it's going to be difficult. The federal minimum wage is about $5 per hour. Actually, it's $7 and something an hour now, isn't it?
Yeah, it's like 7.
$7.25 or.
Or 25. Yeah.
All right. The total of a minimum wage worker's paycheck is dependent on the number of hours worked. Agreed?
Agreed.
So the hours worked is the independent variable, and the total wage is the dependent variable, because how much you make depends on how much you work, right?
Yep.
Find the pay for 1, 3, 5, and 8 hours. Make a graph to represent it. So this is asking us to do what we just did before. All right, so if I've got x and y, 1, 3, 5, and 8. If x is 1, y is 5. If x is 3, y is 15. If x is 5, 25. If x is 8, y is 40. Right? And then if we graph that, what would we expect?
A line.
A linear relationship, right?
Yeah.
Yes, because y equals mx plus b. This is actually called direct variation. We'll get there a little bit later too. Direct. Y varies directly with x. Yes. 5 times x. That's a direct variation. It's not 5 times x, then plus something. Okay? That's not direct. All right? So then you could sketch a graph and do that, and you would expect it to be a linear shape. Yes, I do, when it says to. Your homework is page 113, A through I, 1 through 15, 17 through 29 odd. For accuracy. Okay?